All right, here we go, page 12. So the final transformation is going to be with vertical shift, and that's going to be with this d value. So as soon as you see a number that is completely separated from the rest of the expressions, no parentheses, no multiplication, it's sitting there by itself, that's going to cause the entire expression in front of it to either shift up or down. Okay, so d tells us the vertical shift, and the direction is what you would assume. Okay, so if you get a positive number, that's going to shift it. This is a positive 5, that means it's going to shift up 5 units. If you see a negative 6, you're going to shift down 6 units. The only trickiness is shifting left and right. That we got to be careful that it's opposite way we would expect. Okay, so number 1, we're just going to identify some transformations, and right now we're not going to graph just yet. So we're going to get comfortable writing our transformations, and then page 13 we'll practice with our graphing. Okay. All right. So the nice thing about number 1 is that what's the a and b value here? 1 and 1. So there's no vertical stretch. There's no horizontal compression. We just have to worry about the c value here. So this minus pi over 4. What's that? What's gonna happen with our sine graph here? Yeah, we're gonna shift. Yeah. So this is opposite, right? So minus, we got to think. Normally, we gotta think opposite what we expect. So shift right. And now we see this plus 3 that's all out here by itself. What's that going to do to the graph? That's right. Okay. All right, number 2, we're going to have to rewrite this so that we can get a true read on what's happening with our phase shift. We need a 3 outside a set of brackets here. So cosine bracket 3 parentheses theta. Got to figure out what goes in that space. Okay, so 3 times what gives us pi over 2? Pi over 6. Yeah, so 3 times pi is 3 pi, 3 pi over 6, 3 over 6 reduced to be 1/2. We can always double check, right? Distribute this through, and we should be able to get back to our starting point. Okay, let's find our b value is going to impact our the cycle, the period. That plus pi over 6. Now we're looking at a number that can tell us the true phase shift. What is that? Shifting what? Which direction? Left. And then the minus 1 is going to shift down. Okay. All right, let's practice writing out our function just by the description provided. So number 1, it says a sine function with amplitude of 15 with a reflection. So what is that going to do here? A is going to be what? 15, but then reflection means what's going to happen with our a value? Negative, right? Negative 15. Okay, so we'll handle that later, or if you want to start working it. Okay, so ultimately, we're trying to get into this form, right? So it's going to be plus or minus a sine the bracket b parentheses theta plus or minus c plus or minus d. So we're just trying to figure out what numbers to insert for a, b, c, and d in that form. Okay, really the only work that's required is finding that b value from the period. Okay. So we know that period is 4 pi. We set it equal to 2 pi over b. That's our formula. Cross multiply. b equals 1/2. Okay, so now that we have our b value, then everything else we should be able to just insert in without much trouble. The nice thing about this is that we are creating the function, so we don't have to go through any factoring because we're going to insert it exactly within the form that we want. So the only time you got to do some factoring is if the problem is presented to you that is not quite the way we want it to. But because we are creating the function, we can put them all in the right spaces. Okay, so you guys said -15. Right? B value is 1/2. Okay, shift right pi/2. Plus or minus? Minus. And vertical shift down 10 units. -10. Okay. Yes. Oh, okay. The reason why it's -15 is because we know the amplitude is involved with A, but then there's that key word there, that reflection. So let me highlight that. Yeah, that reflection is what's causing that negative to show up. Okay. All right. Any questions with number 1? Yes.
So why do they keep it in bracket? Just multiply it out or like?
That's okay. No, I prefer that you leave it in this form because this is helping us see that we're looking at the exact phase shift that we prefer. The only time it's not going to be factored is if it's presented to you like number 2. If it's presented to you like number 2, then you always want to write it with that factor out so that what you're looking at is the true phase shift. Okay. Good. Any other questions? All right. So I want you guys to try 2, 3, and 4. Really, the only work that's required is getting to that b value from the period. After you get that period value, then you should just be able to start inserting it into your equation. If you see the words vertical stretch or vertical compression, that's going to be dealing with your a value. If you see horizontal stretch or horizontal compression, that's going to be dealing with your period and b value. Okay. Give you guys a minute or two, and then I'll show each problem so you guys can check. Okay, check number 2. Any questions?
Why is it 5?
Why is it 5? Okay, at the very end, it says vertical shift up 5. So any vertical motion is going to be that last number that you add or subtract.
And 1 you didn't add. Oh, you did. I didn't write that.
Oh, okay, the -10. Okay, try number 3. Yeah, let me talk about that. Those words can be a little confusing here. So, okay. Okay, so that's what vertical compression and vertical stretch is. Vertical stretch just means that your amplitude is more than 1, which is going to cause your graph to look like it's vertically stretched out. If your A value or the absolute value of A value is less than 1, if it's like 2/3 or 1/3, that means you can imagine that your amplitude is not going to go as high as the original graph. So that's a vertical compression. So there's no plus or minus involved. It's just really describing that number in front, right? So here you see that 1/2. That 1/2 means it's a vertical compression because it's not going as high and low as the normal graph. But for number 3, that 4 means it's a vertical compression, vertical stretch. But then the negative is something else, right? The negative is the reflection. So that's why we say the absolute value to indicate that we're looking at the numeric value and ignoring the negative. Okay, here's number 4. Yes.
So, what about like horizontally compressed?
Right. So horizontal compress, horizontal stretch. We don't have to worry too much about that. We're going to be able to just solve that out just by knowing what our period is and knowing what our interval is. So I think all that will just sort itself out. So I wouldn't worry too much about that because we know how to do vertical, horizontal stretch or horizontal compression because we know how to figure out our periods. Okay, that's number 4. Any questions?
I'm not done yet.
Okay.
I'm not even looking at it.
Give you guys a few minutes and then we'll go into our graphing on page 13. Okay, so page 13, we're going to skip number 5 and 6 for now. We'll save that for tomorrow. But I want us to build up with all of the graphing that we've done and then lead into that final step of how to work in that vertical shift. Okay. All right, page 13.
Wait, you can back to number 4.
Which problem?
Number 4.
Yeah, it's up here. All right, so page 13, let's talk about number 7 here. Okay, so we're asked to find the amplitude, the period, interval, phase shift, and vertical stretch. Okay, so let's fill out information that we do know. Our amplitude is 2. To find our period, we first have to find our B value. What's our b value for number 7? B is 1/2, yeah. Okay, so period 2 pi over our b value, multiplied by the reciprocal. Interval is our new period divided by 4. Okay, so now, do we have any phase shift in this problem? Okay, there's no adding or subtracting inside the set of parentheses, right? So there's no need for us to worry about yet. Future problems we will. We don't have to factor out the 1/2. We can leave it alone. We know there's no phase shift. But that +1 is going to do what to the graph?
The vertical shift.
Yeah, vertical shift, so we're going to say up 1. Okay, we're going to do that last. Okay, we'll do the vertical shift last. We'll fill out our table, and then okay, interval is pi, so we're going to keep adding pi. Oops, sorry, there should be 0 here. We're dealing with sine function. So the sine function we know is going to start at 0, and it's going to make its way up, then down, eventually stopping at 0. The -2 we know multiplied by -2. Okay. So let's set up the graph, but now we're going to talk about what to do with that vertical shift. No phase shift, so we can just mark our intervals from 0 all the way to 4 pi. Okay, so this is what's new about this vertical shift. Everything is going to have to go up 1. We're going to do this here. We're going to see that +1 there. You're going to draw a dotted line across y = 1. So wherever that vertical shift is, whatever that number is, that's going to be your new center of the graph. Okay, we're going to imagine this as your new 0. Okay, that as your new 0. So this is how we're going to approach it here. So at 0, we're going to be at 0, right? But this is our new 0 here. So we're going to be plotting our point at our new 0. So whenever we see 0, if there's a dotted line, 0 goes on a dotted line. Okay, -2 is no longer -2. -2 means we're going to count 2 units down from the dotted line. That's what it's going to mean now. So if I'm at a dotted line, if I'm moving down 2 units, where am I going to end up? Negative, right? -1. Okay, so we're here. We go down 2 units, 1, 2, a -1. Okay. All right, 2 pi. 2 pi, we're back at 0, but we see a dotted line there, so we know we're going to treat dotted line as our new 0. 3 pi. 2 is no longer the y value. That's going to tell us how far to move from our center, so we're going to go up 2 units. Where we're going to end up? 3, yeah. And then 4 pi, there's a dotted line. We're going to put it, that's going to be our new 0. So when we sketch our graph, we can see that vertical shift. Okay, so that's really the only new thing that we're doing today, just understanding that these y values are no longer y values. Those are really distance from the dotted line. Okay, distance from the dotted line. And your dotted line is always going to be this number that you see out at the very end. Okay, questions? Okay, all right, number 8, we're going to add a little bit more complexity to number 8 because there's going to be a phase shift. Does anybody still need to look at number 7? Okay, so here's number 8. Well, the nice thing about this problem is that there is no b value, which, well, the b value is 1, so there's going to be a phase shift, but we don't have to find the new period. So we know we can just use 2 pi as our period. Our interval is going to be our normal intervals. Okay, so we're going to see the full complexity at number 9, but we're going to build our way up to it. Okay, so here's number 8. Okay, our b value is still 1, so we can just sorry, 0. We see the plus pi over 2. We know that we're going to have to shift to the left. So minus pi over 2. Okay, so I made my shift to the left. Cosine starts at 1. Multiplied by 2. Create our graph. Mark our x values. Okay. Now we look at that minus 3. We know that's going to shift our graph down 3 units. That's also going to be the new center of our graph. So I'm going to put a dotted line at -3. This is going to be our new 0, which means that these values, we're going to have to rethink what these values mean. These values are not the y values. These, again, are the distance from your dotted line, distance from your new center. Okay, so negative pi over 2, 2. So here's our 0. Where do we move? Up 2, up 2. So we're going to end up where? -1, okay. 0, I know the tendency is you see that 0, you want to put your 0 there, but just keep reminding yourself, that's my new 0. -2, I'm going to count from my dotted line down 2 units. Takes me down to what? -5. back to my dotted line, and then up 2 units. Huh? Yeah, we're going to work on that. I want you guys to try it, but I definitely want to start that first step. Make sure that we can factor that b value out and get that correct c value, and then I want you guys to see if you guys can do the rest. Okay. But any questions with 8? Anybody still need to look at number 8? Yeah. Okay, so you see that -3?
Yeah.
That -3 means that we're shifting everything down 3 units. So the easiest way to think about this is that's going to be my new 0. So I'm going to create my dotted line, and I'm going to imagine this as my x-axis. So when I see a y value of 2, I'm going to think that I'm going to move up 2 units from my dotted line. So I go up 2. If I see 0, I'm going to plot it directly on that dotted line. If I see a -2, I'm going to count 2 units from that dotted line. So think of these as distance from your dotted line. If it's 2, then you go up. If it's a negative, you go down. If it's 0, you stay on the dotted line. Does that help?
Yeah.
Okay. Good. Any other questions with number 8? All right, let's go to number 9. I just want to make sure that we can get that b value factored out, and then I'll let you guys try it. Okay, so this has everything in it. Okay, so there's the a value of b and c and d, so we got to take care of all those parts there. Okay, what's my b value? 1/6. All right, we have to figure out 1/6 times what will give us pi over 3 to pi. Okay, let's always test it out here. 1/6 times 2 pi gives us 2 pi over 6, which is pi over 3. Okay, good. We double checked, and we know that's our correct c value. Okay, so see how far you can get. And after a few minutes, I'll show the progress through each problem. because we had to do this, right? We had to factor that 1/6 out so that we can get our new C value. Because this is not showing the true C value. We gotta factor that out.
That's the only part I'm so confused.
Got it. Okay, so here's what needs to happen.
Yeah, you started.
1/2 sine of brackets. Are you good up to this point?
Yeah.
I factored the 1/6 out.
Take the 1/6 out.
But now I got to figure out what goes in the slot because 1/6 times something.
Oh, yeah.
I got to ask myself 1/6 times what gives me pi over 3. 1/6 times what?
Or 2 power.
It's like,
There you go.
Remember?
9.
I got the concept though.
Yeah, I know this is the hardest part. If you get this part down,
I think other than the numbers, I got the graph right.
yeah, you're right. I think that's what's shifting your graph off a little bit because you didn't get that. Too.
Left 5.
1 second.
So then it would go from
Your keys are here.
0 to negative 2 pi, 3 pi, then
Let me
negative.
put this up.
Are we doing all of the problems in this range?
We're going to stop at number 10, and then homework is 11 and 12.
Yeah, 3 pi.
Just take out 0 minus 1, it's negative 1.
Because I did this shape shift, I did the 3 pi minus the 2 pi.
Isn't that all?
Like, on my chart, on my chart.
I still don't get it. I seriously
I
don't
got
get
it.
it. Everyone's like, oh, it's 1/6.
Oh, because
Oh, and you tried to. Oh, I just did that there.
Like, I did it. Like, what do you
The
do?
accuracy.
Take me out. I literally get everything else. Like, the automatic.
Your interval doesn't.
For which one?
okay, last one here, number 10.
Yeah, you just divide by 5.
Any questions with number 9?
This is it. Really? I think this is the numbers you actually wrong.
Okay,
But not. Exactly. You have to go over it.
number 10, make sure that you can factor that 6 pi out and make the adjustment with your C value.
Oh, I did that now. Yeah, I got it.
2 times.
I didn't get it.
The 1/2. It's math. Yeah. I was doing it.
So we definitely need 3 pi.
I cannot take out the fraction. I can't do that. Period.
Yeah.
Period.
I know, that's what
So it's 3 pi.
5 over 6.
That's more difficult.
It's 3 pi.
Right here. 3 pi for what?
Oh, 3 pi over 4.
Okay, number 10, once you get that 1/6, then everything should be more straightforward. You know you got to subtract 1/6 with your initial subintervals.
Because it's just
Let me know if there's any parts that doesn't quite match with what I have. I can explain anything that that you're struggling with. Good. Okay, so once you're done with number 10, then that's all we have to do today. Your homework is 11 and 12 on page 13. Tomorrow we'll do review. Okay, so nothing new tomorrow, but we're just going to do review. Oh, we also need to be able to look at a graph and be able to figure out what the formula is. So we'll practice with that. And then Monday will be the check-in quiz. Okay, but we're going to spend the first 10 minutes just going over, reviewing, doing a practice problem, and then I'll give you guys the check-in quiz. But again, it's just going to be like this. Okay, I'll give more detail tomorrow.
1/4 minus 3/4.
You good at it?
So,
Oh, yeah.
yeah, so it's -1, okay.
Yeah.
Thank you.
Are you sure?
And then this is 0, right?
One half.
No, wait.